Tom Soderstrom is recognized globally as one of America's top government innovators. As the IT Chief Technology and Innovation Officer, Tom attracts and leads talented teams of engineers, data scientists, and technologists who research and apply some of the most advanced technologies to JPL's overarching mission: the exploration of space and protection of Earth. Tom sits on numerous advisory and awards boards and is a regular speaker on the future of information technology. Please welcome to the stage NASA JPL's IT Chief Technology and Innovation Officer, Tom Soderstrom.
Thank you for that. If my kids saw that video, they go, "What? Who's that?" So what I wanted to do is show some slides, and I could. So I want to talk about AI analytics and the commercialization of space, but it's not going to be a tutorial. It's going to be a very practical, what can we do and what should we do about it? And I'll give you a smorgasbord, or as it's said in the original language, smorgasbord, of examples with the hopes that you will see something that sparks your own solution. I'm going to talk about what that is. We're fortunate today to have my boss, Renee Wynn, here, and there's several other people from NASA. So after this talk, seek us out, talk to us. So let's get started. JPL, I'm not going to ask anybody what JPL is, because once I did, and they said, you make great speakers. That's somebody else. Jet Propulsion Laboratory is a NASA center, and we are nestled in the foothills of California. What's interesting about this slide is we're over 80 years old, and we're an enterprise. So how do you innovate in an enterprise? That's really the key takeaway here. So why do we exist? What is our goals? Our goals are what you see on the screen. They're pretty hefty, and they are for all of humanity. How do we protect Mother Earth? Where did the universe form? Where is it going from? How do we divert an asteroid? And if we couldn't do it, do we have a place to go? So where is Earth 2.0, and have a way to get there? And then, are we alone? Those are the things that we want to answer. And when I say we, it means all of us in this room, including the world. Speaking of the world, I grew up in the forests of Sweden. I could never in a million years have imagined that I'd be speaking to the innovators of the US government in English, no less. So if you don't have these challenges, feel free to exit, because most of us have these challenges, and we do too. So how do we tackle them? I'm going to talk about all of these embedded. I'm in Southern California. I don't know how to surf, but I love watching surfing. So we think of technology as technology waves. And when we have a problem to solve, it's a surfable wave. And if you watch surfers, every so often they just bail. That wave just wasn't used. That's the experimentation. And that's what we're doing. So if we one day could have Curiosity surf the waves, that meant we found a lot of water on Mars and with very happy campers. So how do we bring in new technologies and new ways of working into our enterprise? Our suggestion, build your own IT innovation lab. And I'm going to tackle each of these as I go through the presentation, and with some recommendations at the end. So first of all, we need to tackle the technology waves. Here's what we see as the technology waves. And you notice at 1 o'clock, cybersecurity challenges. They are at scale. They are, as we've heard, unbelievably important. Therefore, we need to build it into everything that we do. Make it easy to do the right thing. So that's parcel of everything we do. Also, NVIDIA, GPUs, quantum computing, everyone becomes a programmer. Ubiquitous computing, what does that really mean? It means your second brain becomes attached to your first brain, and we can do augmented reality on our smartphones, et cetera. Applied AI, it's not a technology experiment. We want to use AI, and we want to impact the vendors to use AI on our behalf, and that's happening, and it's very positive. New habits, the millennials and like Jim would say, gin and tonic, the Gen Y, Gen Z, bring in great habits. They don't have cords. They are wireless, so we try to do that in a conference room. They don't own equipment necessarily. They can rent it, the Uber generation. We want to do the same thing. All this built to one giant tsunami, which is embedded intelligence everywhere, and how do we take advantage of it? So I talked about how we work. So this is how we will work in the future, and it's already begun. This started about 3 or 4 years ago. We started to recognize these trends. We still will use whiteboards. They may be electronic whiteboards, but we still use them. And we want to find answers to questions we don't even know yet. So what does that really mean? When you take a technology approach to it, it's on the outside, how we interact with IT needs to be simplified because IT is becoming more complex. That's Internet of Things. Alexa and all the other variants told us how to speak to the room. Now we're building sensors with the maker generation that are very, very inexpensive, so we can actually monitor our environment all the time. With a new wireless network, 5G, Bluetooth 5, and Wi-Fi 6, we're going to get a lot more data to work from. All that data goes into a cloud. Once it's in the cloud, we need to understand it. We visualize it, combine it with other data, and then we use analytics. Now, once we understand the data, the magic can really happen. And the magic is AI and all of its variants. Machine learning, reinforcement learning, natural language processes. That makes it's actionable. So when we look at equipment, we make sure we can get to the data and that we can control it programmatically. So that leads us to have an intelligent digital assistant, always at our fingertips. You will all have your own, and you probably interact with it through your smartphone. But it means that it will tell you what you need to know when you need to know it, because it knows about you. And you can ask it questions about anything, anything in your environment and outside. So that has led to many new things. We have an Innovation Experience Center. I'll show you that in a second. That means come in here to experience the future today, or solve today's problems with tomorrow's technologies. And if it doesn't work, great. We tried, we documented. If it works, we double down. We're now thinking about creating a JPL data refinery. Data is like oil, it's completely useless until you refine it. Now you can do something. So you now build up your own reusable tools of refining to make it self-service, so everybody can visualize the data. Turns out it's all of those skills that you're seeing there is what's necessary. Building a smart campus. If you walk the floors, you'll see IoT, you'll see smart cities, you'll see smart living rooms. That all can be a smart campus. It's a lot easier for us to deal with. We don't have to deal with politics. We own the environment. We can make it smarter. We can save energy. And we can make people more productive. So that's a big deal for us. It requires retraining, retooling, it's refactoring, but it's worth it. IoT may be the most underhyped thing there is because it generates revenue right now. And we saw it from the previous panels, very innovative ways of working. How do we tie that into our own enterprise? So the recipe for building an innovation lab. Your mileage may vary, but this works for us. First, the facilities. Find the worst facility you can possibly get, and then got it. Take everything out. Now you have an empty space, and what does it look like? It looks like a startup. So then what you do is you take the inhabitants that's going to occupy that space, that, by the way, helped to design it. They put it together. Hands-on is very important here. Then you use privacy, headphones, and collaboration. So each of these folks have different skill sets, and it forces them to work together. In this case, they all started as young data scientists, and then they went to where their passion and our needs dictated.
Privacy off.
Let's take a look at this. I'll talk about it.
Privacy on.
All right, quiet in the studio.
See what a great whiteboard that is?
Privacy off.
Mick hates that. He looks so geeky. But what did we just see? What we wanted to do, it's a very confined space. We're space-bound. And you want the clear glass. You want it open. But sometimes you need privacy. You voice control it, and even approaching it will make it go opaque. And then you're able to use the other side as a whiteboard. We wanted to buy this. Well, it's not our supply list. We certainly can't afford it. So we just bought glass. And then we found film that we now put on the wall that is electrified, and you can see how it works. So what does that mean? It's a fraction of the price. We're going to let it sit there for 6 months, and if it peels off, we know. If not, we'll deploy it across the campus. So it's these experiments that matter and the analysis of the data. We've partnered with facilities, and they're very happy campers. So this is now an experimental facility. And it's very effective. And it's fun. And why not have fun? So it enables smart visits. This is a telepresence robot, lots of them available. This is Cal from Chicago giving a presentation, a tutorial, using a desktop that's in the cloud and using, this happens to Microsoft's Surface Hub. But so nothing is in the room except the people. So they are now getting to learn, and we can get other workforce to participate and get the best skills from wherever they need to be. But sometimes they need privacy. So we put in a phone booth. That phone booth has no phone. Why would they have? We all use our smartphone. But they get privacy. And try to get there at night when nobody was there. That's impossible. It's like a startup. There's always somebody there. This led us to figure out how do we get these. It was IoT, so we started hiring interns. The interns hired interns, and we built up this skill set. And then cloud engineering and cloud architecture, visualization, analytics, and machine learning. And then we're trying to engineer it so that it works for all of the enterprise. And in the end, this interns. So each time we bring in new interns focused on the needs that we're going to have. These were all machine learning and IoT. So this worked for us, and I think the approach works for all of us. We have the skills in-house, and we can bring them in and train them. Instead of buying very expensive expertise, we can actually train them on the things that we care about. So I wanted to talk about a few results. So here comes the smörgåsbord. I'm going to go through some of them quite quickly, so see what you think about these. Let's focus on our favorite planet. This is the Mars 2020 rover being assembled in the JPL clean room. And if you notice, they are wearing bunny suits. We don't want to introduce bacteria into space, and we also don't want to introduce particles into the rover. So if you notice behind it, there's a big display. That display is a particulate counter. And it's expensive. It's $12,500. It only produces data every so often. So we took the idea of maker community and sensors and built another one for 100th of the cost. And it's almost as effective, which means we can now spread them out and measure the environment all the time to make better spacecraft. This is going to be a quick demonstration of using speech. We have hundreds of thousands of contracts. How do you, and this is an expert. So let's listen to it for a second.
Alexa, open acquisitions.
I'm ready.
What is the APO for subcontract 1525702?
The associated PO number is 1563270.
Thank you.
No problem.
So it taught us that it's okay to answer questions, but you really want a dialogue. So by experimenting, we learned that. And now what we found, it was 10 times faster than typing, by the way. The key here is you don't have to know where the data is or how to access it. You just need to know your question. The cloud community calls that serverless computing, and it's a big deal. So what we did is we doubled down on this one, and we created this digital assistant that is proactive. It tells you what you need to do. It queries data where we know the problems are and makes sure that if it isn't consistent, it tells the person. And then you can also answer questions, anything you want. So it's been very powerful. We are doing preventive maintenance using AI on our satellites. It's not like you can go out and fix them, so we need to see it ahead of time. And by using AI, the errors stand out very quickly. And then we visualize it so that it's not replacing the human, it's assisting the human. So in this case, dark colors means more serious anomalies, and you can see how many. So it tells them where to focus. So we've gone from once a week checking it to it's automatic all the time, and it alerts them to the most critical ones. Commercialization of space. I was an advisor to Amazon on building antennas across the world. We have a challenge in launching. It costs a lot of money. Building spacecraft costs a lot of money. Taking down the data costs a lot of money. We really want the science. We want to be able to analyze it. So they built these antennas. And we had a spacecraft that was a CubeSat, and you see it being launched there. It's the space station dumping its trash, which in this case was our satellite, our CubeSat. And it was in collaboration with universities. So that's inexpensive to build. They're much smaller. But how do we get the data down? So as we tested this, our primary antenna failed. We had a catastrophic failure, and the spacecraft went into safe mode. We were able to spin up in the cloud and open source our software so that we're able to track the spacecraft and in the Amazon antennas. And then we spun up another one in another region, so as it's crossing the world, you can do analytics and be much more effective at a fraction of the cost that will be paid before. So this gives us resilience. It gives us much more. Imagine a fleet of spacecraft that all get collaborated this way. Very powerful. Natural disasters. We had a bad earthquake in California, July 4th. So what we look at is USGS databases, and it triggers when there's a Richter scale above a certain level. This then spins up a whole bunch of computers in the cloud that does these images and overlays them. And then we publish that to people who are interested, completely automated. So this guy, Eric Fielding, I have no idea who he is. He was on the publication list, and he looked at it and said, I track earthquake faults. And if you notice here, you may not see it, but there is a line going from about 12 o'clock and down. That was a new fault we didn't know about. So we now have citizen science, and he published that to his community. So it's a way of helping protecting our Earth. Switching to our favorite place, Mars. What we noticed is everything we do has a start and stop date, and it has a critical event. So in this case, what you're seeing is the speed that is flowing through the system. We noticed that some things are slow. We looked at it. They were all because they were paper signatures. We eliminated the paper signatures, and now we sped up the manufacturing of spacecraft and tests. Simple. Should we have seen that? Yes, but we have dozens and dozens of spacecraft with thousands and millions of data items. So when you can visualize it, you can really take action. We landed on Mars, and we detected Marsquakes. That's a good NASA big mission. At the same time, we sent out an experiment, these CubeSats called Marco. And what you see here is what they did. So the spacecraft is launching, and it has the InSight with it. Then it puts out its CubeSats. They free fly for well over 200 million miles. And what we wanted to test is radiation in space. Could a CubeSat survive? And as it remarkably opened and worked, we were able to then see that CubeSats are real. So now we can partner with industry and build many more CubeSats. These served as relays because InSight was on the other side of Mars. And so you saw the landing at the same time as we did. We used serverless computing to save a lot of money and risk. And hopefully you all sent your name to Mars, what it'll be traveling in Mars 2020. So now serverless computing is something we're doubling down on. It'll change the way we work. This is what our next Mars rover will look like. And it will even be able to make oxygen. So next time Matt Damon is stuck up there, he has somewhere to go. And it will have a little buddy with it, a helicopter. So the Mars helicopter was another one of those experiments. Will it work? It certainly can't affect the big mission. But yes, it will work. And it will be able to fly on Mars, which is like flying a helicopter at 100,000 feet. But it's something that industry can help us with later. We are open sourcing the puffers, and they look like scorpions because they can crawl under, they can climb. And they need to be hardy. Again, this is something industry can help us with once we've shown how to do it. They will need to be able to climb. We go to rocky planets. So there's a lot of fantastic research that can be done together. And the open source rover. So this is to a bunch of Cub Scouts. I asked them to build the biggest pile they could and see if they could stump the rover. It's a great way to tire out Boy Scouts. But it's now being built all across the world, and it's forcing engineers, scientists, and programmers and roboticists to work together hands-on, so when they come into our environment, they're trained. And here you can see it next to its father, Curiosity. And you can see it looks the same. So we have a contest going for the public to add autonomy to it, and we're working with startups to add personal AI. And it makes this integration of commercialization in space much more real and hands-on. So finally, how do you build your innovation lab? So our recipe is look at the goals. Is there life in space? Whatever your organization's goal is. Have a strategy of very quick experimentation. And the only failure of an experiment is you don't learn something. That's yet to happen. Put it under the radar screen. Think of moments of engagement. Somebody really cares about something. Use the technologies that facilitate rapid experimentation. The startups call it MVPs, minimum viable products. It works great. Create scrappy facilities, and don't be afraid of breaking them. Have the kids rearrange their room if that's what it takes. It really works. And I look for the energy. Other people come up there to work, then we know it's working. Invite only passionate people. We hire only people who want to collaborate. Doesn't matter how good they are technology-wise, because there's lots of them. If they're not interested in collaborating, then they're not for NASA. And then partner with the end users and industry. They know the problems, and they should communicate about the solution. And then you get a pull for ideas as opposed to us pushing them. And then finally, celebrate failures. Celebrate the experimenters. And this works for us. And if we all do this, hopefully we can answer all those big questions in my lifetime. Help me live a long time. But I really think we can. And with all of your help, we will answer these big questions. So thank you very much for your time. Appreciate it.